Last session of the day at Summit. You made it. Congratulations. Hopefully you've all enjoyed yourselves, had some fun, still got your dignity intact from Bash last night. Yeah? So we saved the best for last for the build and deploy track. Peggy is an absolute rock star at Atlassian, and when it came to curating the content for the build and deploy track, I wanted to make sure that everyone who was in attendance kind of left on a high, and I couldn't think of a better person and a better presentation than Peggy's. So I'm going to stop talking. So please welcome on stage Peggy Kuo.
Think back to the last time you wanted to get something done, but you couldn't because there was some external factor, some external dependency blocking you. And remember how frustrating that felt. For developers, this is a relatively common experience because we have our dev environments and we quite often have a lot of external dependencies and they don't always play nice. So today I'm going to take you through the journey that we took to help us reduce our frustration when we had these external dependencies that blocked us from getting stuff done. Today, my agenda is going to be as follows. I'm going to outline the problem that we had, why we decided to use mock servers, creating mock servers, testing with them, and finally, last but not least, things to look out for when you're using mock servers. So firstly, the problem. A couple of years ago, the team that I was in, we were working on the billing user interface. This billing user interface essentially showed you what your bill looked like as part of your instance. As you can see, there is the products you have, how much they cost you. Off to the side is a bit of information about your credit card details. And on the left, you can update your payment details. The idea behind this is simple. Show a good user interface for our users. Luckily for our team, we didn't need to worry about databases or account management. These were all handled by external systems. All we really needed to do was to worry about the user interface and the user experience. Now, user experience is challenging, but the biggest challenge that we actually had was with our dev environment. Because more often than not, when we first started on this project, this is the screen that we saw. Unexpected error and the spinner of doom. As you can imagine, this is really hard to work with when you're just staring at a spinner that constantly sat there. And this made us really frustrated. All we really wanted to do was to get stuff done, but we couldn't. So why did we have this problem? As I mentioned, we had our code base. This handled the user interface, the user interaction, displaying the information on the screen. But of course, we had to talk to external services. We had to talk to the authentication service to make sure you're both authenticated and authorized to view this information. We had to talk to the accounts system to understand which products you had as part of your instance. And of course, as a billing service or as a billing UI, we had to talk to the billing service to understand how much these products would cost you. All of these external services and more are all really complicated. We initially thought maybe we can spin these dev environments up in our own local environment, but that proved too hard. So we talked to the teams and we asked them, what is your suggestion for us developing against your system? And their suggestion was, how about you depend on our dev environments? We have our dev environments that we use and we test. This way, you don't need to spin anything up. You don't need to manage anything. You just need to point your dev environment to our dev environment. And that is all great, except dev environments are dev environments. They're made to be broken. And so, although this sometimes worked, quite often what would actually happen is we would get an unexpected response. Something was malformed or it just didn't respond as we expected. We'd talk to the team and they'd tell us, we're sorry, a bad merge got deployed to master, and that got deployed to our dev environment. We're fixing that. Unfortunately, during this time of them fixing it, we couldn't work because we were seeing the spinner of doom. Other times, the server simply wouldn't respond. We talk to the team, and they'll tell us, our service is fine, but we've just noticed the service that we depend on, they're going through an upgrade, so everything is down, and they're not responding to us, which is why we're not responding to you. As you can imagine, this is chaos, and this is really frustrating, because if any of these systems are down, we can't do work. And this is what we felt like. We really just wanted to give up. But as developers, we knew we had a problem to solve, and we needed to solve it. We had a look at what we had. We had our system and our external dependencies. Then we thought about, what did we actually need? Well, all we really needed was the information, right? All we wanted was that information from these systems. So we thought, what if we just fake everything? If we fake all the things, we pretend that these systems aren't really there. Instead of having this, let's have this, right? Let's fake out these systems and simulate the responses that they give us. And that is essentially what mock servers are. Mock servers are simple servers that provide dummy data to mock or simulate external dependencies. The next question to ask then is, why should you use mock servers? If you're in the same boat as we were, where we basically could not get stuff done because our external dependencies were blocking us, then this is probably a really easy question, because you can get stuff done. But if you're in a slightly different boat, where you have external dependencies, but they're playing relatively nice so you can still work with them, should you consider mock servers? After all, dealing with mock servers means dealing with more code that you have to manage. And usually that's a bad idea, because that means more chances of bugs, more maintenance overhead. But I think there are still some merits to mock servers that makes them worth considering. And the reason is, this diagram that I had here isn't really true with mock servers, because it looks more like this. Mock servers are usually part of your code base. They live inside the same repository that you're working with. And this simple fact brings out a lot of benefits, and I'm going to highlight 3 of them. The first one is isolation. By having your mock servers inside your code base, everything is isolated and everything is self-contained. By being self-contained, you've decoupled yourself from your external dependencies, and this means everything is more stable. Because if things change outside your realm, nothing will happen, because you've still got your stable environment you're working with. If a bug actually happens, you know that it's something to do inside your system. It could be the mock server, it could be your code base, but you know nothing outside has changed, so you're decoupled from external effects. The next benefit of having mock servers is that you're going to have a faster dev loop. The simple reason behind this is you're talking to localhost. You're talking to a server that is living on your machine. So every time you refresh the page, you don't have to wait for the response to come back from halfway across the world. It is there almost instantaneously. Of course, performance is something that you want to think about. That it is something that you want to think about specifically and dedicate time to it. It's not something that you want to worry about every time you refresh the page to make sure that a style change has happened. And last but not least, a benefit of mock servers, it allows you to write better tests. The reason is simple, because you have full control over the mock server, meaning you can write all the test cases that you want. Happy paths, sad paths, edge cases, anything that you can think of, you can add it to your mock server and add it as an end-to-end test. So the great thing about end-to-end tests is you're testing your system as a whole. So this means you have great confidence that your system is working. Hopefully this has given you an insight into what benefits mock servers can provide. So the next question is then, how do you create mock servers? There are 2 main paths to create mock servers. The first one is third-party libraries, and the second one is to build your own. If you want to use third-party libraries, simply search for them and you can find a whole lot of them. Wiremock, mock server, etc. The list goes on. These third-party libraries all have their advantages and disadvantages, and they all have their unique features. For example, some third-party libraries allow you to specify that a particular request has been made a certain number of times, or maybe even made in a certain order. Other libraries allow you to actually add a delay to your response, and this is useful if you want to make sure that your service responds correctly if your external service is taking too long to respond. The question of which external library is right for you is really dependent on your use case. What language you've written in, how easy is it to integrate, what benefits and what features do you need from this mock server? For us, we actually didn't go down this path. We went down the build your own path. The reason for this is because we really wanted something simple. We wanted something quick and easy. And we were so frustrated, we didn't want to have to read documentation, spike a couple of options, and figure out which one was best for us. So with our build our own, we chose to write an Express server. The reason for this, we were using Node.js, so Express came hand in hand. And when I say a simple server, I mean really simple. It was a grand total of 36 lines of code. In fact, you could probably say that this was the hello world of an Express server. To give you an idea of what 36 lines of code looks like, here is a screenshot of the mock server in its first incarnation. That is it, everything. There's no scrolling required, it's all there. And even better, the part that actually does the heavy lifting is here. This dozen or so line of code does everything that the mock server really needed to do. And I'm going to step you through these dozen line of codes. So the first handler that we did handled a post request to any URL that matched this pattern. So if you send a post request to REST billing product/Jira, it would be handled, and all the mock server would do would reply with a 202 accepted. As you can see, this is being extremely simple and dumb, effectively, but it does what a mock server needs to do, respond to your application. The next handler is a bit more complicated, and that's because it did the rest of the heavy lifting. It handled everything that hit REST/billing. So, for example, if you made this request, a GET request to REST billing instance pricing, it would be handled by this route handler. And three things would happen. Firstly, we would lowercase the method. Then based on the URL and the method name, we would rearrange it to get a path. With this path, this path represents a file on the file system. So we grab this file from the file system, and then we return it to you as a response. As you can imagine, on the file system, this file exists. And inside this file is the JSON blob that we want to respond with. So effectively, what the mock server has done is it has taken this GET request and translated to understand to grab a file from the file system and return the contents of the file back to you. I guess when I said that it was 36 lines of code, I was lying a bit because it really needed these JSON files. Without these JSON files, the 36 lines of code wouldn't do anything. But these JSON files are relatively simple to get because these are the responses that you get from your external dependencies. These are the responses that you'll be working with anyway. And so 36 lines of code and a handful of JSON files later, this red error message, no more. We were able to actually develop in a stable and isolated environment and be productive. We were really happy because we were getting stuff done, our team velocity had increased, and it was all good. Until we realized that we had a bug in our mock server. So yes, you can still have a problem with 36 lines of code. The problem we had was that REST requests aren't all the same. In this case, the post request is a bit different to GETs. And that's because post requests by nature, when you send them, you also have the post data. For us, our service had a bug. We were sending the incorrect post data over to the service. But our mock service, being super simple and super dumb, didn't care about this post data. It still replied with a response, and it was all happy. Unfortunately, when this hit staging and we were talking to a real service, the real service didn't quite agree with this, and it blew up, so we didn't know how to respond. And therefore, we needed to fix our mock service. And to do this, we added an extra postdata.json file, which contained the contents of what we expected inside the post data. Of course, this now meant that we needed to update our mock server to understand how to use this postdata.json. So instead of having an app.all, we split that up to handle a post and a get separately. And in the post, we do one extra step, and that is we validate the post data. So based on the request and the post data of the request, we validate it against the postdata.json file, and if it is all good, we then send the response back. So with this modification, everything was actually awesome. We were developing in a fast and stable environment, we were checking our post data, and it was all really good. And we needed one more improvement, and that was scenarios. So, as you know, everyone is unique, so not everyone has Jira and Confluence in the instance. You have different combinations of different products. So we needed to be able to dev against that as well. Our initial MVP for that was to simply copy and paste files based on what we needed. Now this worked well, except we're developers, we're lazy, copy and pasting files is hard work and error prone. So we thought, let's automate this. Let's make this so that it's really easy for us to change the scenario that we need. And that is why we introduced state into the mock server. Using a bit of imagination, you can imagine that inside each of these directories are JSON files that represent that particular state. So in the all the products directory would be a set of JSON files that represents all the products. With this, we needed to change the mock server a bit again, and that was a way for us to change the state of the mock server. So if you wanted to change to all the products, simply hit the get request state all the products, and that would change the app's state to all the products. App in this case is mock server. And what happens, or the magic I should say, is when we get the JSON file path, it would check the app state, and if the app has a particular state, it would then look into that particular directory. So in this case, we set the state to all the products, so it looks into all the products directory. So no more copying and pasting, simply hitting a REST endpoint, we can actually change the state of our mock server and thus change the state of what we're developing against. And this is really powerful because you can set up any state that you want. For example, if you want to look at Jira activating a transient state, you can as well. And the best thing about this one is, even though Jira activating is normally a transient state, and it will be if you dev against any live dependency, with a mock server, it stays this way for as long as you want. And you can get your designers to come over and check, refresh the page, and it won't change until you switch to a different state, such as a credit card payment error. This one is unique again because it wasn't a normal credit card error. This one was actually really hard to reproduce. This is a payment gateway error. So for some reason, when we were testing one day, the payment gateway gave us an odd response. We captured it. We could never reproduce that again. But we captured it, and now we know if that happens again, we've covered it. So I'll have to admit, with all of these changes and bug fixes, our mock server is no longer 36 lines of code. In fact, it's something like 442 lines of code last I checked. Yes, it is a lot more, and it is also a lot harder to understand. You can't fit it on one screen. You have to spend more than 10 minutes to understand what's happening. You need to poke around, try a few things, maybe ask a team member why and what is it actually doing. Despite this complexity though, I think the mock server is still a lot easier to handle than your external dependencies because you still have full control over it. You've written it, you understood it, and you can change it the way you see fit. And because of this, when we started our next project, we decided to duplicate this idea of mock servers. We decided to write another mock server and to help us develop and be more productive. There were two main differences with this new mock server. The first one is we didn't have state. Instead of state, we actually encoded the scenario into the URL or into the header as a parameter. If you wanted to test the Jira activating state, this is what you would do. Put it into the URL and put it into the header. The other difference that we did was we had smarter JSON. This is something that I made up myself, but instead of returning the JSON blob, we return an array of interactions. So you can specify request-response pairs. For example, the first request-response pair that you might need is something like this. If the mock server receives a request that has Jira.onDemand as part of the post body, it will respond with a 200 OK and 3 elements: Jira Core, Jira Software, Jira Service Desk. But of course, the mock server also knows how to respond in a different way. Maybe it can receive a request that only has Jira Software as a post body. And if this is the case, it responds with the 200 OK with just one element in the product key, Jira Software.onDemand. So as you can see, this really means that the mock server can be powerful and flexible. Of course, the second iteration meant that our mock server was again a bit more complicated for it to parse this interaction array, but it was really worth it. And with both of these mock servers, we felt like we had succeeded. We had really achieved something that made ourselves productive, less frustrated, and we were able to get stuff done. We were able to develop in a stable and isolated environment with working tests. And that brings me to the next part, and that is testing with mocks. When I mention testing with mocks with my colleagues, the first thing that comes to mind is unit testing. Testing each and every component of your system to make sure that it's working. And this is not surprising because testing with mocks is something that we do a lot with unit testing. We want to test one particular component, so we mock out everything around it in order to make sure that we are testing that component and that component only. And unit tests are great. They're quick to write, easy to write, quick to run, and you can write a lot of them. The problem with unit tests, though, is even though all of your components may be working, you're never really sure if your system will work when you put it in together as a whole. Because after all, we're humans. We make incorrect assumptions or we forget things. And that is why we have end-to-end tests, to make sure that everything is working from end to end. But usually end-to-end tests are a pain to write because you need to bring up your environment, you need to bring up all the services that you depend on, and they're slow. And they're also hard to write because you need to make sure that all the scenarios that you want to test can be replicated in these environments. The good news is, with mock servers, you've sort of solved this problem. You've solved this problem in your dev environment, and you can actually translate this across into your testing environment. You can use your mock servers as your end-to-end test environment. And that is what we did for our billing tests. When we opened our billing overview page, the mock server would go and grab the JSON files and return them to you so you can see your billing overview. And this meant that we could then go and expect that certain elements on the page existed or were of certain values. And the good thing is, because you have your mock servers behind, backing these tests, you can easily change the state to something else. And now the mock server would check inside this directory, give you a different screen, and this means you can now expect a certain element to be a different value or to not exist anymore. And this is really powerful. And the best thing is, because again, these mock servers are on localhost, they will run faster than if they were an actual service. And this means that your devs will more likely run these tests because instead of taking 30 minutes, they might only take 3 minutes. Unfortunately, there are things to look out for when you're using mock servers. They are not the silver bullet. They won't solve all your problems. There are two main things that I guess I've come up with, and that is, the first one is that mock servers usually start off very simple. You have one use case, maybe two, but as you've heard, we quickly realize that mock servers very quickly become complicated beasts. They can become huge, they can have bugs, and the more complicated something becomes, the more likely that odd things will happen. And unfortunately, this does mean that you will have to spend time working on your mock server to make sure that it's behaving as expected and maintaining it as well. But for us, this trade-off was very worthwhile. The second thing about mock servers to look out for, and probably the most important, is to make sure that you are mocking reality. Make sure that your mocks are up to date and accurate. Let's take a look and see why this is so important. So firstly, you have your code base, and you depend on an external service. But this external service is hard to get up and running, it's hard to get stable. So you decide to write a mock service for it. As with all mock servers, you need to know how the external dependency responds to you, so you copy that particular response. You go away and you start developing against your mock server, and everything is good. But of course, as you're developing, so is the other team. And as time passes, this other team will very likely change the way they respond to you. And this is crucial because your code base now takes on the shape of this particular JSON file that your mock server uses. And when you talk to the real service that has a different JSON file and that arrives at your code base, you don't really know what will happen. You're not quite sure how it will behave. Maybe the change that they made was insignificant and everything is good. But more than likely, they've changed something that you cared about. And so in order to make sure that you're mocking reality and that your mock is up to date and accurate, you want to compare them. The first reaction that most people have when you want to compare things is to compare them against each other. After all, if you compare several things against each other and they're all the same, then you're good, right? But what if they're different? What if your mock server is different to the real servers? Is it the real server that has made a mistake? Maybe they made a typo and did a bad merge, so they've made a mistake. Or maybe you've made a mistake, you've made a typo, and you've read the contract incorrectly. You really don't know, because when you compare them against each other, it's hard to tell who's wrong and who's right. In fact, you could both be wrong. So in order to make sure you are mocking reality, what you want to do is to compare against a central source of truth, a schema that defines exactly what you expect. In our case, we used JSON schema. And this is a really powerful language that allows you to define exactly what your JSON object should look like. And you can see it, you can find it on jasonschema.org. Here is a quick example of our JSON schema file. So here we have our JSON schema, and it says that the JSON object should be an object. And it must have 5 fields. It must have host name, current and next billing period, active and deactivated products. If it has more than these 5 fields, that's okay as well, because it only requires these 5 fields. But if any one of these 5 fields is missing, then the schema check will fail. And on top of this, these 5 fields must satisfy the following properties. The host name must be a string. Current and next billing period, they must be billing period definitions. These are custom definitions that you define in the file, and I will get to them a bit later. Active and deactivated products, they must be arrays, and these arrays must contain product definition items. So these custom definitions, billing period, as you saw earlier, has to be an object, and this object must have 3 fields: renewal frequency, start date, end date. And these particular fields must also satisfy these particular constraints. So as you can see, the JSON schema file is a really simple but effective way of defining exactly what you want in your JSON response. And once you have this schema definition, it means you can start comparing your mock server and the real server against this one definition. If they both pass, then everything is good, because this means that both of these files contain what you expect. They contain what you have defined to be important. However, if one of them fails, this means that something has gone wrong. This means it needs your attention. For if the external server fails, you should go and talk to them to understand what has changed and why has it changed. It could be an unintended mistake. Or maybe they could have changed the contract and they need that change to be there. And if that's the case, you need to go back, change and update your schema definition, update your mock servers, and of course, update your code base to handle this new change. The great thing about this is you are now making sure and validating that your mock servers are real or as close to the real server as possible. And this means that even though you are still dependent on the real server, you've cut that and pushed that way to the edges. So instead of depending on the real server every time you refresh and checking your styles or checking if things look right, you've pushed that to the edge so that you only depend on the real server when you feel like everything is good and they just do a sanity check. You can also put the schema definition checks into continuous integration. And if you have them running every night, you can be confident that if they pass, then everything is good. But if they fail, again, this means it needs your attention because something has changed in such a way that it may break your code base. So it will be time to go and talk to that team and understand what has changed. The great thing about this, again, is this failure may occur 3 months down the track when you're not really actively working on your current service. And so if you ask me, being pre-warned that something may fail that's completely out of your control and you have the chance to fix it before it reaches production and affects customers will make any developer happy. So in the future, if you're ever faced with a headache like this, an environment that is extremely hard to deal with and that is causing you a lot of frustration, remember that you can use mock servers to mock and fake all the things. But if you do use mock servers, also remember that you need to make sure your mock servers are mocking reality and that you have a schema definition in place and that you're running it constantly. And once you've done that, you can start to develop in isolation with a fast dev loop and, of course, an amazing suite of tests to make sure your systems are working as expected. Thank you for listening, and I hope your dev experience in the future will be less frustrating and more productive. Questions?
Okay. Cool. Thanks, Peggy. We've got time for a couple of questions that are on the app. Did the team write integration tests? If so, were they separate from mock server tests?
Yes, we wrote integration tests and they were separate. So I'm not, how many of you went to Ben and Maori's talk earlier today? So that was our integration test. So we used PACT to make sure that the integration between our systems were correct. I guess that our contracts were satisfied.
And if you didn't go, you can watch it soon, I think, on the website. Second question here. Was there a time that third-party services were considered again as the build your own was becoming more complicated?
No, actually. We probably should have gone back and revisited, but I think we had invested so much effort and time into our custom, I guess our build our own solution that it didn't seem worthwhile to go back and rebuild it.
Where in the dev test pipeline do you recommend moving from testing against mock servers to testing against real servers?
Good question. So we moved between the two. So when we were developing in localhost, we used mock servers. And then when we wanted to do more thorough QA, we went to staging. And that was when we were talking to the staging servers, because staging was a lot more stable, and it included all the changes from, I guess, all the different services. And that was really useful for us to have the quick dev cycle inside our localhost and dev environment. But then when we wanted to do larger QA and blitz tests, to go into staging.
Sure.
Who did the schema definition? Your team or the services team?
We did it. And
The services team should do it, right?
no, actually.
Why
So
not?
that's a good question. So the reason that we were responsible for it is we define what we need. So for example, the authentication service, they service many other teams. For us, we may be interested in, say, the username and the instance name, but their response may contain a lot of other things. So another user of their service might be interested in the username, the instance name, and I don't know, the creation date. And if they change the creation date field to be created on, we don't care, so we never specify that. And that's why we specify what we need, and only if those things change do we go, oh, we need to pay attention. Yep.
I'll take one more live question. Anyone? Yes?
I've heard you've been using the BACT, so
Yes.
couldn't you use the output of the BACT to validate the exact schema?
Yes, we can. So
Okay.
the story, I guess, behind this is mock servers came first, then we started using PACT. So we effectively have a bit of overlap between our PACT tests and our mock server schema tests. And because the schema tests didn't take that long to run, it seemed like a waste to not run them. Plus, we were depending on the responses to test, so we had to make sure that the JSON files were still up to date.
Awesome. Thanks, Peggy. And thank you, everyone, again. That's it. You got 20 minutes until, I'll stand away from the speaker, 20 minutes until ship it live. If your stomach can handle it, I think we'll be serving alcohol too. And anyway, thanks, everyone.